Radians and Degrees. There are three common units that angles are measured in. The first is degrees. This is the oldest system and dates back several thousand years. Here, the circumference of a circle is divided up into 360 units called degrees. If we mark a point on a line, the angle the line makes at that point is 180 degrees, or that can be written as 180 with a small circle, which is the symbol for degrees. A right angle, or the corner of a square, is 90 degrees. Now we use a protractor to measure angles in degrees. We can see this done. We see the angle is about 61.1 degrees. Another unit that's used mainly on the continent is called gradians. When the metric system was introduced in France, it was decided that angles also should go metric, so gradians were used instead of degrees. Now there are 100 gradians in a right angle instead of 90 degrees. The symbol for gradians is a small superscript g. So we write 100 gradians as 100 small g, or 100 gon. The kilometre was defined to aid navigation. The circumference of the Earth is 40,000 kilometres, so the length of an arc of one gradian around the equator is 100 kilometres. Now the third measure of an angle is called radians. If we have an angle theta and we draw a circle radius 1 unit at the vertex of the angle, then the angle measured in radians is the length of the arc subtended by the angle. In this case, with circle radius 1, in radians the angle theta is the length of the arc. If the length of the arc is 1 unit, then we have an angle of 1 radian. If we draw a triangle with all sides equal to 1, it'll be equilateral, so each angle will be 60 degrees. If we bend the side AC into the arc of a circle, the distance AC will now be slightly less than 1. But the angle B will be 1 radian, so 1 radian is slightly less than 60 degrees. In general, the angle at the centre of a circle of radius r is the length of the subtended arc divided by the radius. So theta is equal to L over r. We use the symbol 2 superscript c, or 2 rad, to mean 2 radians. Note, calculators can work in degrees, gradians or radians, so always check when you use a calculator that it's set to the correct units. Converting between radians and degrees. The circumference of a unit circle is 2 pi. The angle in a complete circle is 360 degrees. So 2 pi radians is equal to 360 degrees, or pi radians is equal to 180 degrees. So 1 radian is 180 degrees divided by pi, which works out to be approximately 57.295 degrees. Now radians are usually awkward to write. 180 degrees is 3.14159 radians. In fact, that's the number pi and it does not terminate. So we often leave the measure in terms of pi. 180 degrees is equal to pi radians. So 90 degrees is pi by 2 radians. 60 degrees is pi by 3 radians. 120 degrees is twice that, so it's 2 pi by 3 radians. 45 degrees is a quarter of 180, so it's pi by 4 radians, and 135 degrees is 3 pi by 4 radians. 30 degrees goes into 186 times, so 30 degrees is pi by 6 radians, and 150 degrees is 5 pi by 6 radians. To convert from radians to degrees, we multiply by 180 divided by pi. So some examples. Convert to degrees 2.5 radians. Well, 2.5 radians is 2.5 times 180 divided by pi. That is 450 degrees divided by pi, or 143.239 degrees. Pi by 5 radians is pi by 5 times 180 divided by pi, which is 36 degrees. 11 pi by 12 radians is equal to 11 pi by 12 times 180 over pi, which cancels down to 165 degrees. Note, a quick way to change from radians to degrees is to replace pi in the numerator by 180 degrees. So if we've got pi by 5 radians, we can change the pi into 180 degrees over 5, and so that's 36 degrees. And to convert from degrees to radians, we multiply by pi over 180. So if we were asked to convert 240 degrees, we would multiply 240 times pi by 180, which cancels to 4 pi by 3. If we had 75 degrees, we'd multiply by pi over 180, and that would cancel to 5 pi over 12. If we've got 300 degrees, we'd multiply that by pi over 180, and that would cancel to 5 pi over 3 radians. Now, the following is an exercise. You can pause the video at this point and have a go at them yourselves. When you've done them, you can restart the video and I'll go through the answers. Okay, let's have a look at question number 1. In question 1, we've got 30 degrees. Well, to convert that into radians, we multiply by pi over 180 degrees, and that cancels to give pi over 6 radians. In part 2, we want to convert 210 degrees. Well, we multiply by pi over 180 degrees, and that comes to 7 pi over 6 radians. In part 3, we've got 72 degrees. Again, we multiply by pi over 180, and that cancels to 2 pi over 5. In part 4, we've got 40 degrees. We multiply by pi by 180, and that cancels to 2 pi over 9. In part 5, we've got 70 degrees. To convert that to radians, we multiply by pi over 180, cancel down, and that gives us 7 pi over 18. And in part 6, we've got 155 degrees. Well, if we multiply by pi over 180 degrees, that gives us 31 pi over 36 radians. In question 2, we're asked to convert the following angles into radians, giving the answer to 3 decimal places. Well, in part 1 we've got 90 degrees. To convert it to radians, we multiply by pi over 180 degrees. But this time we're working it out on a calculator. So we get 90 degrees is equal to pi by 2, which is 1.571 radians. In part 2, we've got 25 degrees. We multiply that by pi over 180. Working it out on a calculator gives us 0.436 radians. For part 3, we've got 67 degrees. Again, we multiply by pi over 180, and that gives us 1.169 radians. In part 4, we've got 300 degrees. We multiply by pi over 180, and that gives us 5.236 radians. In part 5, we've got 48 degrees. We multiply by pi over 180 degrees, and that gives us 0.838 radians. And in the last part, we've got 196 degrees, which when we multiply by pi over 180, gives us 3.421 radians. In question 3, we're asked to convert the following angles into degrees. Now, the easiest way to do this is simply to change the pi on the top with 180 degrees. So, pi by 5 radians is 180 degrees divided by 5, which is 36 degrees. 4 pi by 9 radians is 4 times 180 degrees over 9, which cancels to 80 degrees. 3 pi by 4 radians becomes 3 times 180 divided by 4, which is 135 degrees. 3 pi by 10 becomes 3 times 180 degrees over 10, which cancels to 54 degrees. 5 pi by 12 radians becomes 5 times 180 degrees over 12, which becomes 75 degrees. And 4 pi by 5 radians becomes 4 times 180 over 5, which is 144 degrees. In part 4, we're asked to convert the following angles into degrees, giving the answer to 1 decimal place. Now in this case, none of the angles contains the letter pi. So to convert, we need to multiply by 180 over pi. So 1.5 radians becomes 1.5 times 180 over pi, which is 85.9 degrees. 2.3 radians becomes 2.3 times 180 over pi, or 131.8 degrees. 6 radians becomes 6 times 180 over pi, or 343.8 degrees. In part 4 we've got 1.35 radians, so that's 1.35 times 180 over pi, or 77.3 degrees. In part 5 we've got 8.4 radians, so that's 8.4 times 180 over pi, which works out to be 481.3 degrees, and 0.3 radians is 0.3 times 180 over pi, which is 17.2 degrees.